Hi, Randy Bush, IJ. We're the first commercial deployer of IPv6, but I'm not going to talk about that. This is mostly social political talk, but my coworker Maz will be actually opening the kimono and talking about it starting at a meeting in 2 weeks, and it'll make it around maybe to the next NANOG. We will transition to IPv6, or we're going to have a real v4 horror with massive natting. Get over it. The issues are when and how. The marketing fantasy that has been going on in the past has not been helping it. It confuses people, it makes expectations that aren't met, etc. So, this presentation can seem negative, especially the next string is going to be dispelled myths. But it's really trying to get rid of the rose-colored glasses so we as operators can actually get on a deployment path. Okay, Lucy, my dear friend, summarizes it. No more BS, no more excuses, shut up and spend the money. You don't spend it now, it's going to really cost you more later. It was a stressful movement. She's normally much more polite. What should have happened is as the IPv4 free pool slowly depleted, and as IPv6 deployment went out because IPv6 worked, things would be great. And we'd be nearing the crossover point today, and IPv4 would not be an expensive resource and a scarce resource because IPv6 would be doing well. What's actually happening is the IPv4 pool is running out quickly because IPv6 is not being deployed. If you see that today it shows a little inflection in the v6 deployment, many of my friends tell me they didn't think I was that much of an optimist. Okay, and so what is going to happen consequentially, excuse me picking on one of these two, is that v4 is going to start costing you a lot of money. And that's going to be the driver for IPv6. It's not going to be 3G cell phones. It's not going to be rocks falling on cars. Why is it happening? No transition plan, declared victory, no real long-term plan, no realistic estimates, no support for folk on the front line. Victory will be next month. Is this the invasion of Iraq, IPv6, DNSSEC, or all three? Okay? IPv6 is incompatible with IPv4 on the wire. This just stuns me. This just stuns me. The darn things don't interoperate. The real reason was a conspiracy. I want to dispel some myths. IPv4 is running out. No, it's the IPv4 free pool from the IANA. It's going to run out in a few years. Frank Selensky gave a fair curve 10 years ago. Jeff and others are giving it us down to the minute. But IPv4 will go to a trading model. That statement's not really wrong. It's already gone to a trading model under the table. It's going to come up on the table. Okay, registries are going to become title agents, not allocators for v4 space because there's no more to allocate. And to that end, the RIRs are developing full multi-RIR software with X509 certificates, and you've already heard me rattle on about that for 2 years now. IPv6 transition is easy. It isn't. It was designed with no thought to operational transition. It's incompatible. This could have been avoided. One example of how is if v6 was variable length addressing, with a v4 being a variant with 32 bits and a couple signals. There are also no simple, useful, scalable transition or translation mechanisms. IPv6 eliminates that. Hell no. An IPv6 only site, excuse me for being fast, by the way, I have too many foils. A v6 only site cannot reach IPv4 internet because it can't source from a v4 address. There will be significant v4 internet for decades. So a v6 only site is going to need an IPv4, a little bit of IPv4 space to NAT out there without. So IPv6 is going to increase NATs, But at least it's for the short to medium term and they can go away. Okay? It reduces routing load. No, it won't, because multi-homing is exactly the same as it is in v4. Traffic engineering is exactly the same as it is in v4. There's no new T model. Enterprises will slice and dice their IPv6 32s to handle branches, etc., just like they do in v4, and the routing table will fragment more and more over time. Okay? Transition will ease routing is another myth. This is the market base. We're going to charge for V6 advertisements. The problem is it's operationally complex because I'm trying to charge somebody 4 relationships away. The average is 4 relationships away because that's how many ASs are transited on the average of a packet. Okay? This could push back on fragmentation, but the financial trade-offs I don't think are there. IPv6 space is effectively infinite. 64 bits goes to every LAN. Some folk use 64 for point-to-point. I remember when you had to use 24, a full /24 for point-to-point with RIP protocol. Well, that was wonderful. Here we go again. Our IRs are giving away /32s, and we're going to think of them as the equivalent of /8s today, 15 years from now. IPv6 has better security. Unfortunately, it doesn't. It was promised to. IPv6 was the recipe in either case. IPv6 was supposed to be IPsec mandatory, but it isn't. Okay? IPsec is still difficult to turn on, difficult to manage. This needs to be fixed. Okay? IPsec does not work well in a mixed 4 and 6 environment. Think about trying to run to your home v6 IPv6 target from a v4-only hotel room. It's true that address space scanning will be somewhat harder. That's helpful. But think about massive botnets scanning in a black market and telling each other where the hot space is. IPv6 increases battery life. I loved this one. What it really was the IPv6 was running with NAT and the v4 was running with no NAT. And to keep the NAT translation alive, the v6 cell phone had to keep saying, howdy, 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 howdy. And of course, that burned battery. Okay, this tells us more about v6 marketing than about technology. It's going to be incrementally deployable, not for an enterprise, because you have to be able to run it in the enterprise, it's going to have to work all the way from your back end in your database, through your million lines of code, through your front end, to your customer, okay? For ISP provisioning systems, monitoring, billing, allocation, DNS the works. And we all need vendor support. Routers fully support v6, not 100% in hardware, especially not if you add ACLs. Folk don't know this because there's no good IPv6 testing equipment available. So vendors can tell us wonderful things and we can't disprove it. Some vendors are not even spinning the ASICs across the line. Not all v4 features are supported over v6, et cetera, et cetera. There will be no static numbering. AutoConf will save us all, but it's not widely used in enterprise and won't be because of the security issues. They want DHCP, they want lockdown addresses, they want to control it. And similarly, backbone addresses for logging, CALIA, et cetera, and just management in the ISPs. Okay? IPv6 is being seriously deployed. Pioneers are doing it. You know, we're one of them. Early adopters are actually just early series adopters, enterprises, users are finally starting to enter the game. The actual measured traffic is negligible, but at least that makes it look like the routers can handle the traffic. But there are starting to be good stories of how people have done it. Clarinet is especially good, saying exactly how they deployed it. Here's what they did at the router interfaces, et cetera, et cetera. So there's starting to be good stories. So they're paths that you can follow. People are starting to publish recipes. Okay? IPv6 will replace v4. Given lack of vendor support, not real soon, it's far easier to use NAT and v4, and this scares the hell out of me, and should scare you. It is just as likely that we are going to end up in a highly NATed v4 universe. And by highly NATed, I mean multi-home sites putting /32s or 31s or 27s in the routing table and you having to accept them. Millions of prefixes. Not good. Okay? And that will be forever, not something we can talk about getting rid of in 10 years as IPv6 seriously transitions. Okay? Because it requires no new expense or technology to the user. That sells. Okay? It's architecturally horrible, but it makes sense financially. The reality is 96 bits, no magic, garage. Okay? But we need those bits. The key question's how to use them. How to transition without losing anyone or anything. What we can do is make the transition easier. What we have to do is that. How? We have to actually face up to what the problems are and identify them. For the protocol issues, we have to ask the IETF to fix them quick. We have to push vendors to support v6 and the tools to transition. And by push, I think we probably need large machinery. Okay? And the registries have to prepare to deal with title to v4 and v6 space, which they are doing. The registries are out front here. What we should not do is pretend there are no problems. We should not give away v6 trace in strange ways to market v6, because what's going to sell v6 is v4 runout, not all the fantasies we said that there would be the killer app or the killer this or the killer that. What's happening is we're being killed by v4 runout. And something else we should not do is make messes we have to live with forever just to get people to take v6. These are some areas of concern where ISOC and some people from ITF, Russ Housley, et cetera, kicked me into starting to try to get a taxonomy of where the issues are. Okay, and as you can see, this is really starting to crawl up the layers and then goes horizontally to the different types of user bases. There's a wiki that has this extensively. There'll be a pointer to it in a minute. I'm going to run through the next slides even faster because they're just critical examples from there, but you should know most of them, and the ones you don't know probably don't interest you. Here's the wiki. It's very pretty, and Kamanji's up in the corner. ISOC's hosting it. Thank you, Lucy. Global issues. You know, how does a v6 only site, oops. How does a v6 only site get to the internet via, i.e. a v4 only site? They don't. We've been through that. Administrative infrastructure. DNS, Bind 9 seems to be heading there and supporting v6 pretty well. There are issues of how resolvers look for things and how that affects application that you've read about on the mailing list recently. Registrars need to support glue records, et cetera, et cetera. RIRs are developing software, as I said. DOCSIS, the MTU limit hurts, the MTS support is lacking, et cetera. 802, the protocols are spec'd there, they're just not being rolled out. Backbone engineering, there's core routing, conversion to dual stack is slow, but it's getting there. Provisioning, address assignment, DNS, all the back-end stuff, billing, DHCP v6 and DNS integration's not there well. Monitoring and measurement over D6. And how wonderful to make this stuff run, I got to buy new line cards. Great. The last kilometer, I guess I'm in the States, last mile. Authentication, etc. PPPoE does not work with v6 and it will not. You are going to move to IPOE or DHCP. Back-end databases again, etc. How to scale the combo. This is a quote from Alain Durand, who's here. Excuse me, Alan, for stealing it. How to scale the provisioning system to deal with millions of customers using stable prefix delegation. CPE ain't there. The $50, the Soho home stuff. Teredo does not really scale. Shim6 does not solve enterprise or large site and has deployable issues with security and routing model. Enterprises, I said, it's got to go all the way through my millions of lines of code, NFS appliances, etc. Applications. Where's the web page with a matrix of application by platform showing which are v6 capable and a nice clickable link showing me how to configure it? Many applications which support v6 have poor performance, either because of themselves or how resolvers work or stack issues. And therefore, the early adopters turn v6 off. Yuck! We're shooting ourselves in the foot. There's a silly issue with XP. This is an interesting example. Thanks, Jeff Streifling. Email is a mandatory application. It's one of the golden applications. Everyone needs to be able to send email to anyone else on the internet. Due to spam, you cannot run an open SMTP relay anywhere. So people cannot just put out public SMTP relays saying, hey, this one runs dual stack, so if you want to send mail, go to it, because spammers are going to use it about 36.2 microseconds later. So every v6 site needs to have the ability to SMTP to arbitrary other v4 sites. Therefore, every one of them needs an agreement, right, with some dual stack relay until the whole world is dual stack. And that means that if for an end user, for a home user, that's fine. You have to go to your upstream ISP today. You're used to that. For the enterprise, that means I, as the enterprise, must run a dual stack relay. Okay? No hack. How come things are better in Japan? How did it get that way? How come it's easier and more widely deployed? Because folk with vision, mainly Mirai Sensei, convinced the government early that v6 was needed and wise. Japan's very good at investing early. The government actually gave, excuse me, this wouldn't work with yen symbols, so I stole dollars, supported IPv6 research with money. They supported IPv6 development, actual product development by the industry and vendors. And the government even gives tax incentives now to end enterprises which become v6, which deploy IPv6. Okay? So the government, instead of regulating, beating, et cetera, used a carrot. Amazing. Okay. What can we do? We want one internet. We do not want to fragment it. So during transition, everybody has to be able to talk to everyone else at will, as we do today. And we'd love to keep the end-to-end principle as much as possible, and if we have to compromise it, we would like to compromise it in a temporary fashion that we have some hope will go away. Dual stack. The core needs to be dual stack during all of transition, or the kludges will escalate. The further dual stack goes towards the edge, the easier it will be. This means all the configuration, management, measurement, et cetera, that the ISPs among us need to do really needs to be simplified. There are 5 phases of the transition. We're in the first, denial from both sides. We can ignore brain-dead, misdesigned, botched IPv6, and on the other side is IPv6 is perfect, and those greedy fools just have to deploy it. Okay? Neither are right. This is the internet, we are a shared community, etc. The next phase will be dual stack with IPv4 dominant. Then there'll be about in balance. And then we'll be dual stack with v6 dominant. And then we'll actually be to the IPv6 internet and getting ready for the IPv10 transition. Okay? NATs. The end-to-end principle, we love it. But because v6 is on the wire and compatible, we don't got no choice. There will be NATs. Get over it. NAT PT is what we need. At the edge, the enterprise, consumer, etc., need to run v6 internally, but need to get out to both v4 and v6 people. So, when v6 becomes dominant, it's the converse. The IPv4 only sites will not want a NAT so they can talk to the v6 internet. The ITF needs to standardize 4 to 6 NAT for ICMP, UDP, TCP, RTP. what happened to, this slide got botched, I'm sorry. It's supposed to also say SNMP and HTTP. And somehow I lost that. With ALGs, locked in, standardized, so I have vendor interoperability and vendor choice, plug and play. Okay? The ITF is originally, in July of this year, took the original NATPT and moved it to historic. That means we're not interested, don't do it. Okay? Which gives you a clue about how head in the sand the ITF has been about the problems of operational transition. That has changed. The ITF is now working and reworking NATPT, and we wish them Godspeed, and we beg they do it promptly. Okay, there are security issues with NATPT. It's not too bad. DNSSEC will have to terminate on the NAT if translating. But IPsec can go through. Okay? The ALGs will be critical. And IPsec, we really need IPsec to be made easy throughout the internet. Okay? There's going to be pressure on routing. IPv4 address space, oh, I'm doing great. Price escalation is going to drive NAT right up, and it's going to put pressure on routing. If it takes a $10 million router to deal with 2 million routes and the churn that it is, 96% of ISPs die. Right? It's going to be like you have to buy a full telco switch. You will die. And enterprises cannot be multi-homed on the default free zone because they don't want, only monster enterprises will want to spend $10 million to be multi-homed. So all size routers from enterprise border to ISP core need to handle significant routes with churn. And I assure you, they do not today. Don't hack to get around this, such as tunneling from the enterprise border to some $10 million core router, because you will be owned. And think TLA, NLA, for those of you who remember, and think 10 monopoly ISPs, and be very, very fearful. Okay? Because lack of market, it's going to be some years before all router vendors support dual stack at line rate with ACLs. They can't go to their management and say, we need to roll those ASICs. Okay? Some of them already even started spinning some of the ASICs that are needed. Okay? And we need, as I said before, all vendors to be able to do it because I don't want to be vendor locked. So Cisco, if Cisco can do it and Juniper can't, or vice versa, it doesn't do me any good because I'm going to be owned by the vendor. So, no vendor pissing contests, thank you. We need good IPv6 test equipment because they claim wonderful performance, but I need to know it. Stop adding features to v6 to make it marketable. Okay? It's going to sell because of the v6 runout, and adding features just gives vendors and operators the, oh, well, we're not going to do it right now because that's coming around the corner and we'd have to do it all over again. We need very little change, NATPT especially, and then let's just deploy it. Give us a chance to deploy it without playing with it and without dragging our energies down into arguing about ULA or and the same kind of goes for the registries. Let's settle on some policies over the next few months, and then let's move forward. This is a very hard thing for all the ISPs, all the enterprises, et cetera, to do. Give us a chance to do it without having to spend all our time chasing our tails in political meetings or vendor waiting, etc. Okay? ULA is a great example of this. Because it's address-based, the borders need to filter the packets, not leak, et cetera, et cetera. Look at the example of 240/4 and what it's going to be to clean that up because we hard-coded a border. Okay? IPv6 space is supposed to be infinite. Give them real IPv6 space and to heck with it. You know? So, to summarize, what I want out of the ITF is NAPPT and no more features. Okay? Out of the vendors, dual stack on the fast path with ACLs. Line rate, or as near to the line rate as you've ever gotten, but at least as good as IPv4. No games, no BS. Sorry, the routing table is going to fragment no matter which way we go down the road. I wish it were otherwise. Keeps me up at night. You got to handle those routes with churn. And there are significant monster routers out there that you can't even load the routes into, let alone have churn. Okay? ISPs, get dual stack rolled out, start converting your back ends, etc. We have to do it. Governments, incent, don't regulate. And I think this may be the last foil aside. Oh no, here's the URL that I promised you of the wiki. There's something right at the top of it. This right to Randy is now a lie. There's instructions right at the top of it if you want to contribute how to become an editor. And there's probably half a dozen editors now. Significant people who have contributed, Alan Durang, et cetera, et cetera. And thanks, Taryn, for support, my employer, and specifically Lucy, Rob Austein, Russ Housley, Yariako, for actually, you know, helping and beating on me to do some of this stuff.
Daniel Blair with Cisco. Can you go back to the summary slide? Enterprise border routers do not need 2 million routes, ever. I know personally of customers that are turning off full routes and doing traffic engineering with default routing to the internet. Also, there are non-BGP multi-homing techniques that are available today that get you about 80% as good as BGP multi-homing. So the notion of enterprise multi-home customers injecting more specifics into the DFC under those circumstances is not realistic.
You want to know what I hear?
Yeah.
We can't do it, so you got to hack.
I just know it works for the customers that I've dealt with.
Oh, and here guy's the guy that wants to dig a tunnel, or is it a grave?
So your comment about IPv6.
Who are you, Dino?
I'm Dino from Cisco. Your comment about making IPv6 go as fast as IPv4, it will never happen because of the packet format and the address format. If you want IPv6 to go to at 100 gig, we'll have to build a 200 gig chip and you'll get IPv4 at 200 gig. You can never make it go line rate like IPv4. The address is too long. You have 2 to 4x cost and lookup because of v6. Every implementation that I've worked on 4 different hardware implementations of IPv6. It will not go as fast as IPv4.
Point taken. Yari?
My name is Yariako. I come from the IDTF, and I work for a vendor. In any case, I really liked your approach of losing the rose-colored glasses and looking at the real problems we have. And also like what you said about stopping modifying the protocols and moving on with actually deploying them. That's really important. And you sort of get different perspectives from different organizations. Like on the IETF, on some of the lists, it feels almost like every hour there's someone who's proposing rearranging the bits somehow in some neighbor discovery protocol or something like that. And that's just not the way forward. But I did have a couple of comments. So one thing is that I think you overestimated I think you expected the compatibility of V4 and V6 to be easier, or the on-the-wire compatibility to be easier than it would really actually have been. So I'm not quite sure that's so easy to do, but in any case, that's water under the bridge, and we shouldn't really go back to the 90s and redesign everything. So let's work with what we have now. The other comment is that the IPsec stuff, I think we really are over the pixie dust story right now, and IPsec is good for certain things, it's not good for all things, and it's really the same for V4 and V6. And there are configuration problems, ease of use, and so on, and I don't think anyone is claiming at this point that you have one tool that will solve all your security problems. So use the right tools for the job.
What percentage?
What percentage? What?
I realize that's silly, but I mean, is the kind of thing you're saying IPsec is going to only solve half the things I think it's going to be good for, 80, 90%, or am I really in trouble?
Yeah, I think it's very good for VPN. I have yet to find a very good match for other problems, but I'm still looking.
Thanks.
No more questions. Thanks very much, Randy.